Java development, production and consumer project. This is a famous problem when we talk about threads or in general concurrency. Production is going to be something responsible for producing a data and consumer is going to be responsible for consuming the data. In our case, we're going to simulate this scenario using a list to fill the data. So the production is going to fill the data inside of the array list and the consumer is going to take that same array list and read all the data. Well, welcome to the class. We're going to see that and problems with unsynchronized method plus the synchronized block. Let's go. Open your environment and find me when you have your environment already set up. I have here the production class, the consumer class, and thread colors class. This class contains all the strings that we're going to use to append into the string that we're going to build during this project. Production is going to run as a thread, so we have to implement the runnable interface right here. Ctrl O just to override the run method, and we are going to have two attributes. One is going to be the list that's going to contain the data from where we want to put the data that we produce, and another is going to be the string, which is going to be the color that our console is going to use just to show the outputs from the production. Okay, the two attributes are what I said. Private is going to be an array list of strings data pack. Now we have the string color, add a constructor with these two, and override the method run. Let's create a bunch of values here that we can add. So let's say values to add. Put something that you want here. I'm going to just with A, B, C, and O, A, B, C, D, E, and what? Okay, F. Okay, it's enough. Now let's add all this data into our data pack. So for data type is going to be string. Let's say string to add. Inside of values to add, what we want to do is to add these values into our pack. So let's pick the string to add. After we add, we want our thread to sleep just for 1 second. We'll have to surround with try and catch, and here we're going to say system out interrupted production. Easy. All this info is going to be, or instructions more technical, are going to be inside of our try. And before we add, let's say we are adding, let's put what we are adding right now. We are adding the string to add, and let's put the color here. Okay, so this info we're adding plus the string that we are adding is going to be colored by the value of the string that's going to represent a certain color. It's going to be a different color. Okay, here we have. Now let's focus on the class that's going to consume our data. Well, we won't take too long to implement this class since it's something pretty much equal. Small differences are going to be found. So let's copy this, because when you consume, you have to get a color and array from where you're going to consume. Okay, and now let's just make the same process. Implement the runnable interface here. Ctrl O, while true before all, because we want to execute infinitely. We don't know when the data is going to be available. We're going to say if our data pack is empty, what are we going to do? We're going to continue. What's going to be continue for us is going to be go back to the loop. That's the meaning of continue. If it gets to the line 20, that means the data pack is not empty, so there is data to be consumed. We're going to say if our data pack that get the value at position 0 is equal to the keyword that we want to use, that's going to mean there is no more data. No more data. We have to take this and add here in the production, because the production also after every operation needs to add this string. Okay, let's just print here adding the last one, and we're going to say our data pack that add this string here. Fine, let's go back and continue to code. If there's no more data, in other words, what are we going to do? Okay, we're going to simply break. Okay, break. Otherwise there's data, guys. We're going to system out color plus what? We're going to say remove it by thread plus, let's get the thread name, current thread, get name plus remove it by the name of the thread that remove it plus data pack that remove what's going to be at this position. Now it's time to go to our main method and make this work. Let's create an array list with our string and call this pack. This is going to be new array list, and we have, let's create the production, call this the production, is going to be new, the production, and here we're going to pass what? The pack and a color that we want to use. So let's go to thread colors dot, this one is going to be green for us. Okay, let's create instance of our consumers. Okay, first consumer, this is going to be equal to new, and here we're going to pass the same value here, same object, because that's the key point to see the interference or discuss about the interference and see how to solve, because in real world application we don't create multiple instances of objects that we want to read data from. For example, your bank account, if somebody wants to deposit and you want to make you want to withdraw your money, the same instance is going to be running, and one of these operations is going to be performed first and the next operation is going to be performed. So get used to that, and you have to guarantee the integrity of all the data. Same instance, because we want to see the same values right there. If there were multiple instances, how could we guarantee that the data inside of those instances of our bank account would be the same? We couldn't do that, so we have to pass the same instance here and discuss. That's why Java and other programming languages allows us to deal with this type of situations, and we're going to discuss more in this lesson. Since Java 1.5 we have inbuilt tools that allows us to deal with threads. Let's continue to write. I just wanted to let you know that. Let's go to thread colors dot, now it's going to be purple, the consumer. Let's create the second one. Okay, this is going to be new. Let's pass the same pack, and now what's going to be cyan. Okay, I don't have one. Okay, I have. Let's create threads that are going to have our consumer objects. This is thread, this one is going to be the first thread, and this first thread is going to be new equal thread, take the first consumer. Okay, you've done. Let's give this thread a name, set name that's going to be thread, oh no, okay, thread 1. Okay, let's close here, create another thread. This one is going to be the second thread, is equal to new thread, and work with the second consumer and second thread. Let's set the name to be thread 2. Okay, let's just start a thread to the production using this type of let's pass the production start thread 1. This is the thread 1 or the first thread. Let's start the second thread, also start. Before we start running this, we have to think something. Let's go to what? Let's go to this part right here. All these instances are going to share the pack where the data is in. Let's suppose the following scenario. We have two threads, first one and second one. The first one is the first to execute this block. Okay, while true, it checks if the data is empty. Let's suppose that at position 0 our pack has A, and at position 1 our pack has no more data. It sees if it's empty, it's not empty. So what happens? Before it executes this else block, it gets suspended. Thread 1 is suspended. Okay, let's comment here. Thread 1 is suspended. Then what happens? Thread 2 starts to execute and checks if the buffer or your array or data pack is different from no more data at position 0. Oh yes, it's different. Then it removes what's at position 0. Okay, this thread 1 was suspended at the else block. Okay, and thread 2 remove it what was at the position 0. Okay, fine. Thread 2 goes again to check if the data is empty, and then it tries to continue, but it stops here. It doesn't check if the data that get value at position 0 is equal to no more data. Thread 1 gets resumed. It had previously been here and it was suspended here at else block. So now it's time to remove what is at the position 0. At position 0, what we have no more data. It's removing the string that contains the info no more data, and that's wrong. You see a problem that we can have. So you should think about that, because the string no more data is the string that the producer and the consumers use to know that they can't remove anything. Okay, but it removes. And let's resume the thread 2. The thread 2 was here. It wanted to execute the if statement. It was to execute. Now it says if data pack that get at position 0, well, at position 0 we don't have nothing. Another problem, null pointer exception. So our program has problems. Let's introduce a concept here. Let me open for you. Okay, intrinsic locks. Intrinsic locks. When a thread invokes a synchronized method, it automatically acquires the intrinsic lock for the method's object and releases it when method returns. Okay, what we have to do is to synchronize our method, give access to that data pack only one thread at a time, and after the thread has access to has performed all the operations using our data pack, we have to release that access so that other thread can use. So the first thing that's going to happen is that when you have the thread inside of your execution, you have the access to that lock. So you're going to be locked. You're going to execute what you want. And what we're going to do after that execution happens that we wanted, where we saw that this can be a potential vulnerability to this shared resource. After we execute the code right there, we are going to release the lock. Another thread is going to take that opportunity to execute, and so on. Well, let's come and implement that. We are here and we know that our data path cannot be accessed, so we're going to use the synchronize here. Synchronizing is just going to allow us to synchronize only this specific resource of this method. Data pack is the problematic resource here. So let's say synchronize it, and the locker, the monitor or the object that we want to monitor, this is one, data pack. From if to else, stay right here inside. Now let's go to this production. You also need to be synchronized. So let's synchronize this with our data pack, because this is what we want to monitor. No more data. When we add, we also need to do this, and this is our data pack. It's done. Well, by doing this, you've prevented many things. Let's run this code and see the outputs. Building, let's wait. Parsing the Java, building, synchronizing, scanning files. So index, we're adding a, remove it. Okay, thread 2 had the opportunity to remove, thread 1 had the opportunity, thread 1 also had, adding last one, that's it. And any no thread, they also remove it. The no thread also no. You didn't see any thread here removing the end of file. Okay, end of file is the last file that we have in our data pack, which is no more data. No more data was removed here. You can see we are adding, we are adding, we are adding, we are adding, we are removing. Okay, you can see they are trying to access. Okay, so A was moved by thread 1, B also, D also, C by thread 2, D 2, F 2. That's it, guys. Simple. Subscribe. We need to have your subscription here, and yes, we deserve it. So follow us and let's move to the next lesson.